Hi, this is your video for Unit 2, Lesson 3. So today we're going to take what we talked about the other day, which is drawing asymptotes and making asymptotes, and extending that and actually graphing our rational functions. So I want you to take a second and I want you just to think, what are some other key elements that we're going to need? So we already know asymptotes are important, but what else might we need in order to graph? So just think to yourself for just a second. Okay, let's just review for just a second. So rational function, remember a rational function is a function that is a ratio of two polynomials. So we already talked about how to add and subtract them. We talked about how to simplify them. And we talked about how to find all of our asymptotes the other day. So now it's time to start talking about graphing them. So what else? So we know asymptotes, right? We know asymptotes are a thing. We have our vertical asymptote. Remember, we never, ever, ever cross the vertical asymptote because the whole thing is vertical asymptotes are where the denominators are zero, and that can never, ever happen. So we don't cross the vertical asymptotes. Horizontal asymptotes are just all about ratios, the ratios of those two front terms. And so we can cross those. We kind of forget, but we can. And then same thing with slant. Slant is just about the ratios of the front terms. There's nothing illegal. So there are no spots of being undefined. So we can cross those just as a reminder. So then after asymptotes, what else is there that we might want to know? Well, points, right? Points are the other thing that we want to know. All right. So, 2 points that are really, really easy to get is our x-intercept and our y-intercept. So we're going to add those two things to our important elements. Okay. Okay, so let's just do a quick review and then let's add x-intercepts and y-intercepts. So if you remember, for our vertical asymptote is when we set the factor denominators equal to zero. So over here on the right, I have a rational function that is in full form, and then I have it factored. Okay, so x squared minus 4x factors into x and x minus 4. X squared minus 16 factors into x plus 4 and x minus 4. So remember from the other day, in order to get our horizontal asymptote, we're going to set our bottom. Well, first of all, before we even do that, right? Before we even do the bottom, we look and we notice that we do have something that we will be able to cancel. We have the x minus 4s that we can cancel. So then the vertical asymptote is what is left over, right? So our vertical asymptote is when we set x plus 4 equal to 0. So in other words, our vertical asymptote is -4. So we know we have a vertical asymptote here at -4. And then remember that whole becomes our canceled factor, okay? Our whole becomes our canceled factor. So if we set that equal to 0, that's x is equal to 4. So our whole is at 4. And then to figure out our y, remember we plug it into the simplified version. So if I plug in 4 into the simplified version, I would have 4 over 4 plus 4. In other words, I'd have 4 over 8, which is 1/2. So that means 4 1/2 is where my whole is. So I'm going to go to 4, I'm going to go to 1/2, and I'm going to put a little hole there. All right. Then remember our horizontal asymptote is the ratio of our leading coefficients. So before we factor it, so leading coefficients before we factor. So remember, if our degrees are the same, if our degree is lower on top, then it is y is equal to 0. If our degrees are the same, then it's the ratio of our numbers. And if the degree on the top is higher, then we have our slant asymptote. So I'll say that again as a reminder. If the degree on the top is lower, it's y equals 0. If the degrees are the same, it's the ratio. If the degree on the top is higher, we have a slant asymptote, higher by 1. So in this case, they're the same, so it's the ratio. So y is equal to 1. So y equals 1 is my other asymptote that I have going here. And then I don't have a slant asymptote. Remember, we cannot have a slant and a horizontal at the same time. We have one or we have the other. Okay, so now we're starting to get the shape of our graph, but we need a little bit more because we need to know exactly where my curves sit. And the best way to know where my curves sit is to find some points. The easiest points to find are x and y intercepts, okay? So x and y intercepts. If it's an x-intercept, then that means that it's something sitting on the x and my y is 0, right? My y is 0. So what ends up happening is this f of x becomes 0 and you solve. Well, let's think about this. If I have 0 and my function ends up being x over x plus 4 after I simplify, okay, then when I go to solve this, I'm going to multiply both sides by x plus 4. But what happens is over here on the right side, it cancels, and on the left side, it just becomes 0. So now notice essentially what 0 is equal to x. So notice what essentially ends up happening is I end up just setting my numerator equal to 0. Okay, because when you take that f of x and you make it 0, you're going to multiply both sides by the denominator. The denominator is going to disappear. So to get your x-intercept, the easiest way is to set your numerator equal to 0. So in this case, my numerator is x, so x equals 0, so 0, 0 is my x-intercept. Okay. Then my y-intercept, remember my y-intercept is any time that my x is 0, okay? And I'm trying to find my y. Well, let's think about this. If I plug in for x to be 0 into my function, then I have f of 0 is equal to, I'm going to my original function here, 4 times 0 over 0 squared minus 16. So notice everything wipes out except for my constants, okay? Except for my constants in my number. So then that means that my constants represent my ratio or my x-intercepts. Now, you say constants, everything dropped out on the top, right? So on the top, I end up with 0. On the bottom, I end up with negative 16, so I get 0. So my y-intercept in this case is also 0, 0, which doesn't surprise us, right? Okay. So the big idea is that we're going to, for the vertical asymptotes, we're going to set my denominator equal to 0. For my horizontal asymptotes, we're going to set we're going to look at the ratio of my front terms. For my x-intercepts, we're going to set the numerator equal to 0. And for my y-intercept, I'm going to set my constants into a ratio. Now, what I do want you to notice is that all of the x information comes comes from horizontally information, and it comes from the factored form. So I get my x information, I get my x-intercept from the top, setting the top of the factored version equal to 0. I get my vertical asymptotes, which is x equals, by setting the bottom equal to 0. So both of these have to do with x. Then if I look at my vertical relationships, the ratios of my front or my leading coefficients gets me my horizontal asymptotes. And the ratio of my backs gets me my y-intercept. So again, everything has to do with y. So x's are the factored form. X information is factored form horizontally, setting it equal to 0. Y information is vertically in the pre-factored form, looking at the ratios. All right. And I know that might be a little bit overwhelming, so we'll do more so that you can kind of see what I'm talking about here. Okay. So let's look at the next example. So here it says, find all key elements of the graph, asymptotes and holes. Okay, so the first thing I'm going to do is I'm going to try to factor. So I notice that I could probably, I think I can group this. So if I try to group that, I get x squared, x plus 2, and I'm going to take out a negative 1 and I get an x plus 2. On the bottom, I factor into x plus 2, x minus 2. But the top still isn't done. So the top is going to be, let's see, x squared minus 1 and x plus 2. On the bottom, I still have an x plus 2 and an x minus 2. I know I have a factor I can cancel. I'm going to wait though here. I'm going to go one more step. So I see that x squared. So I'm going to have x plus 1, x minus 1, and I have x plus 2. And then on the bottom, I have x plus 2, x minus 2. Okay, now I see that now that it's completely factor form, I do have something that I can cancel. Remember, a cancel turns into a whole. So let's build this. So we have our vertical asymptote. Vertical asymptote is x's. I get it by setting my remaining denominator equal to 0. So that's going to be x is equal to 2. So I have a vertical asymptote at 2. Connected to that is my whole. Remember, your whole is whenever you take your canceled one, that would be x is equal to -2, and you plug it into your original equation. So if I plug that, well, actually, it doesn't have to be the original equation. It can be the simplified version. So if I plug it into the simplified version, I would have -2 plus 1, -2 minus 1 over -2 minus 2. So I end up with -3/4. So my whole ends up being at -2, -3/4. So I'm going to mark that, -2, -3/4. I have a little hole right there. Okay, that's all X stuff. Y, remember Y stuff. The horizontal asymptote is Y. Horizontal asymptote comes from the front. Okay, so it comes from the front. So I have x cubed over x squared, which means my horizontal asymptote, I don't have one because my degree on the top is higher. But that does mean I have a slant asymptote. Now, remember, for your slant asymptote, you can go to your original problem and we can do long division, or we can come back here to our prefactored form. If we cancel this out, we can use this prefactored form in order to also just do synthetic division, because now I'm dividing by degree 1, so I can use synthetic division. So you can either use your simplified form or you can use your prefactored form, but prefactored form, I got to do long division. I don't want to do long division. So I'm going to do synthetic division. So that puts 2 on the outside. That puts a 1, a 0, and 1, because on top is x squared minus 1. So then if I drop this down, 1 times 2 is 2, plus 0 is 2. 2 times 2 is 4. And remember, we don't care about the remainder. This becomes our slant asymptote. So y is equal to x plus 2. So I'm going to start at 2, and I'm going to go up 1 over 1 to get my slant asymptote. And it is important that we are as accurate as we possibly can on this slant asymptote, because we don't know quite where our graph is going to land, and sometimes those points get pretty darn close in the graph. Okay, so there's my vertical asymptote. That's setting the denominator equal to 0. Horizontal asymptote, looking at those front ratios, which actually this one turned into a slant asymptote. Then remember, our x-intercepts are when we set the top equal to 0. So all of our x's are horizontally factored form. So our x-intercepts are going to be at -1, 0 and at 1, 0. And I'm getting that by setting that top equal to 0. So -1, 0 right there and 1, 0 right there. Then our y-intercepts are when we set the ratio of our backs. Okay, now again, this is the unfactored form. So y's, you get everything from the unfactored form. X's, you get everything from the factored form. So that's the ratio of -2 over -4. So that would be 1/2. So that means that my y-intercept is 0, 1/2. So 0, 1/2 would be right here. And now I already have a really nice shape going of my graph. Okay. All right. Now we're one step away from actually graphing, right? We're looking pretty close to being able to connect the dots. So let's talk about what we need to do to actually graph these things, okay? So our first step is going to be, of course, to factor the numerator and denominator and simplify. All right, we need to have it in the unfactored form for all of our y information, our y-intercept and our horizontal asymptote. We need to have it in the factored form for all of our x information, our x-intercept and our vertical asymptotes. So we need both forms. So we're going to go ahead and factor and simplify. If we are able to simplify, then remember we have a whole. Then determine all of our key elements. That's what we just did on the last example. We found all the asymptotes, we found all the wholes, we found y's and x's. Now, what happens is when you do that, sometimes you get a really good picture of what's going to happen in part of the graph. For example, if I go back here with all these points going on right here and knowing that my graph approaches my asymptote, I know I probably have some kind of graph that looks something like this, right? Because I should be approaching my asymptotes and I should be going through all those holes. So I get a really good idea on what's going on this side of my vertical asymptote, right? I know what's going on there, but I don't know what's going on here, right? I have no idea. The information I've gathered so far tells me nothing about that spot, but there's a curve there, so I need to go find it, okay? So that brings us to our third step. Our third step is determine any additional points, okay? I want you to find 1 point per intersection, and I want you to find 3 points per middle section. So what am I talking about middle section? So we're going to have some graphs where we have a vertical asymptote here, a vertical asymptote here, and let's say we have a horizontal asymptote here, okay? So I want you to find at least 1 point over here on the end and over here on the end. That way it tells you is your curve above where's your curve at, right? Is it up towards the top? Is it up towards the bottom? Something like that. Okay. So on the ends, I want 1 point. And that point can be a hole, that can be x-intercept, that can be y-intercept. Okay. So on the ends, I want at least one. In the middle, we need to have at least three. Okay. Because if I have a point, let's say I have a point like right here, then we don't know what happens in the middle. Two things could happen. We could have a parabola like U, or we could have kind of like a squiggle. So if I find out that a second point is here, I still could either have a U or I could have a squiggle, right? So I have to figure out which one do I have. So I'm going to put in a third point, and sure enough, if I figure out my third point's right there, then I know for sure I have a squiggle going on, okay? So that's why we want 3 points in the middle section, because we got to figure out, do we have a U or do we have a squiggle going on right there, okay? And then after that, we should have enough points to get an idea between the asymptotes and the points. We should have enough information to sketch the curves of our graph. Okay, let's try it. Let's look at our first example here. Okay, so my first step is I'm going to go ahead and write this in factored form as well, because remember, I need both. So the denominator is going to factor into x minus 2 and x plus 1. Nothing cancels here. So remember, we get our x-intercepts by setting this, our vertical asymptotes by setting this equal to 0. So our vertical asymptotes we get by setting our denominator equal to 0. So in this case, x is equal to 2 and negative 1. So there's one of those graphs that I was talking about where we're going to have a middle. All right, we have no holes, nothing canceled, so we have no holes. I don't know why I wrote nuns. Then remember horizontal asymptote, y's have everything to do with our front numbers. So our front numbers is our horizontal asymptote. In this case, my top is smaller than my bottom, so automatically my horizontal asymptote is y equals 0. Since I have a horizontal asymptote, I do not have a slope, or I'm sorry, a slant asymptote. Okay, now to get a little bit more information. So the next thing we're going to get is our x-intercepts. Remember, our x-intercepts we get by setting our numerator of the factored form equal to 0. So that's our x-intercepts. So that means that our x-intercept, if I set that to 0, it's 0. So 0, 0 is an x-intercept, so right there. And then our y-intercepts we get by setting or by looking at the ratio of my constants. In this case, I don't have a constant. So it's going to be 0 over negative 2. So 0 divided by negative 2 is 0. So y-intercept is 0, 0, 2. Okay, so again, I want you to kind of visualize that when we have I'm going to kind of do this a little bit below here, but whenever we have a fraction like that, notice in that visual, okay, our top set equal to 0 is vertical asymptotes, which is an x. Our bottom, or I'm sorry, our bottom set equal to 0 is our vertical asymptotes. This top equal to 0 is our x-intercepts. Our front number ratios is our horizontal asymptotes, which is a y thing. And our back number ratio is our y-intercepts. So now you can maybe see what I'm talking about when I say the horizontals give us all of our x information, the verticals give us all of our y information. The horizontals, it's always setting the factored form equal to 0. The verticals, it's always looking at that ratio coming from the original equation. Okay, so hopefully that's a good visual for you. Okay, but I need that out of the way because right now I got all my key elements and I did not get a lot of information about my graph, okay? So that means I need to plug in some extra points, okay? So I'm gonna plug in a point for each end section. So what am I talking about? So notice how the vertical asymptote split me up into 3 sections of my graph, okay? So for each domain section, that's my x's, so it's domain. For each domain section, I need to get some points. So the left side, I only need to get 1 point. So I'm just going to pick a point and I'm going to plug it in. So I'm going to pick -2. -2 would be on my left side. So I'm going to plug it in. You can plug it in anywhere. You can plug it in the original equation or you can plug it in the factored form. I like doing the factored form. I think it's a little bit easier. On the top, you'd get -2. If I plug in -2 into here, that would be a -4. If I plug in -2 here, that'd be a -1. So I end up with -2/4, or in other words, -1/2. So -2, -1/2. Okay, there's my point. That's enough. That tells me that from this point, I'm going to approach my vertical asymptote, going down, and from here, I'm going to approach my horizontal asymptote going up. Okay. Now, we've mentioned that we can cross horizontal asymptotes. We're not going to cross them unless we have mathematical information that tells us we should. Okay. Okay. Then in the middle, remember we need at least 3 points in the middle. So I'm going to pick 1 point to the left, which would be -1/2. And I'm going to pick a point to the right, which is 1. And I've already done this math, but if I plug in -1/2 into one of my original equation or my factored form, I get 2/5. So I've kind of already done that math for us. So that means I have a point somewhere around here. And if I plug in 1, I get -1/2. So if I plug in 1, I get -1/2. So notice how I have a point that's above my middle point and I have a point that's below my middle point. So that tells me in the middle, I have a squiggle. And then last but not least, I need to get a point on the right side. So I'm going to plug in 3. Again, I've done the math for us. So I get 3/4. So 3/4 is here. So that tells me that this curve is above my horizontal asymptote. And so it looks something like this. Now, remember I said we're not going to cross our horizontal asymptote unless our math tells us. Notice here, our math tells us to cross that horizontal asymptote because of the points that we plugged in, okay? Now, I will tell you, typically we do not have to plug in this many points, all right? I kind of chose a hard one to kind of start with so we could see the big picture, and then we could kind of back off a little bit, all right? All right, let's look at another example here. It says, find all the asymptotes, holes, and intercepts, sketch the graph of the function, be sure to test enough points. Okay, so again, the first thing I'm going to do is I'm going to factor. I don't have anything to factor here, so I'm ready to start finding my key elements. So I'm going to set my denominator equal to 0. That's going to get me my vertical asymptote. So my vertical asymptote is x equals 1. I didn't cancel anything, so I don't have any holes. My horizontal asymptote is the ratio of my front numbers. This time, my numerator, my top, is bigger than my bottom, which means I don't have a horizontal asymptote, but I automatically have a slant asymptote. Since I'm dividing by x minus 1, I can use synthetic division. So I'm going to have 1, and then on the top, I have 1, 0, 0. I have two zeros, one for the x value and one for the constant. And then drop the 1. 1 times 1 is 1. Drop the 1, drop the 1. And again, I don't care about my remainder. This becomes my horizontal asymptote. So y is equal to x plus 1. So I'm going to start at 1, go up 1 over 1. And again, we want to make sure that we're pretty darn accurate on this slant, just in case some of our other points are awfully close. Okay, now we need to get some points so we know our curve. So remember, the top we set equal to 0 to get our x-intercept. So x-intercept is going to be x squared equals 0, but if I square root both sides, I just get x to be 0. So my x-intercept is 0, 0. My y-intercept I get by setting my constants equal to 0. And again, in this case, my top, it has a 0. My bottom has a minus 1, so 0 divided by 0 is 0. So 0, 0 again. Of course, if 0, 0 is x-intercept, it has to be a y-intercept, right? Okay, so that is enough information for me to get my left side. So we only have one vertical asymptote. So we have a left side of a graph and we have a right side of a graph. So remember, your curves are determined by your domain. So your sections that your vertical asymptotes have made. So that's enough for me to know that I'm going to come up, I'm going to hit this, and I'm going to come back down. And again, make sure you're always approaching those asymptotes. But I don't have anything for my right section, so I do need to pick a point for my right section. So I'm going to pick the point 3. That gets me a little bit away from my vertical asymptote, makes it a little bit easier. If I plug 3 in, it would be 3 squared over 3 minus 1, which is going to give me 9 halves, or in other words, 4.5. So 3, 4.5 gets me to be, let's see, 4.5. Oh, good thing I did that slant asymptote really well because that did end up pretty darn close. But that's enough for me to know that my curve up here is here. And again, the points that you're graphing are not necessarily your turning points. You do not have to turn your curve at the points you're graphing. The points that you're graphing just tells you where your curve is at. So just do kind of a natural curve going from one asymptote to another, wherever that curve may be. Okay, how are we feeling? I hope we're feeling okay. Okay, take a second, go ahead and pause the video, and I want you guys to try this one either on your own with your table partner, okay? So pause the video, and when you come back, we'll go over this one. Pause. Okay, let's go over this one. So the first thing we need to do is we need to factor the top and the bottom. So the top factors into x plus 2, x plus 1. The bottom factors into x plus 4 and x plus 1. So I do have my x plus 1's cancel, so I'm going to have a hole. I know that. And now I'm ready to get my key elements. So remember, my vertical asymptote is when I set my bottom equal to 0. So vertical asymptote is going to be x equals negative 4. Drop a little line right there. We just said we are for sure going to have a hole. Remember, a hole is whenever we set the canceled thing equal to 0. So that is x equals negative 1. And then we plug that into the simplified version. So simplified version would be negative 1 plus 2 over negative 1 plus 4. So I'm going to end up with 1/3 here. So my hole is at negative 1, 1/3. So I'm going to go draw negative 1, 1/3 would be about right here. Okay, my horizontal asymptote is when I look at the ratio of my front numbers. So my degrees are the same, so it's the ratios of the constant. So in this case, it's 1 over 1. So my horizontal asymptote is 1. So I'm going to draw in my horizontal asymptote. Since I have a horizontal asymptote, then I automatically do not have a slant. Okay, now for our new pieces. So x-intercepts, remember x-intercepts are when we set the top equal to 0. So if I set x-intercept is when I say x plus 2 equals 0. So in other words, it's going to be -2, 0 is my x-intercept. My y-intercept is the ratio of my back numbers. So my y-intercept is the ratio of my back numbers, so 2 over 4. So that's 1/2. So 0, 1/2 is your y-intercept. Remember, make sure that you're writing these in proper form, which means as points. Okay, so again, my graph has been divided into two different sections with my domain. I have my left section and I have my right section. I have plenty of information for my right section to go ahead and connect my dots. And guys, just a reminder that a hole does count for a point. So if the only thing you have in that domain section is a hole, that counts. You know where your graph's going to be. So that means all I need to know is what's happening on the left side. So I'm going to pick a point to plug in for the left side. So I'm going to pick -5. And again, you can plug this into the original equation, you can plug it into the factored form, or you can plug it into the simplified factored form. So I like to do the simplified factor form. So -5 plus 2 over -5 plus 4. So I'm going to end up with -3 over -1. In other words, just 3. So -5, 1, 2, 3. So that's enough for me to know that my curve is right here. How did you do? Okay. Last but not least, let's talk about a special case here. All right. So let's look at this one. So first of all, I look at the top and I say, I don't think that can factor. That's x cubed, that goes down to x squared, then it goes down to fourth. There is no fourth term for me to group. I'm kind of stuck with that. And I know the bottom doesn't factor. Okay, so we're going to jump right in and we're going to start trying to find our key elements. So we say, okay, vertical asymptote, remember, is when I set my denominator equal to 0. So in this case, when I set my denominator equal to 0, it's 2x squared plus 1 equals 0. So if I solve for x squared, I'd get 2x squared equals -1. So x squared is equal to -1/2. But then when I square root, I'm going to end up square root of -1/2, which is an I, right? So if I end up with an I, then that means I don't have a vertical asymptote. Because remember, we don't graph I's. So if we can't graph I's, then we can't graph an I vertical asymptote. Okay, so no vertical asymptotes. Okay, well, that's weird. Well, I definitely also don't have a hole, right? Because I didn't have anything to factor, so therefore I don't have anything to cancel, so I don't have a hole. Okay, well, maybe my horizontal asymptote will help me. So my horizontal asymptote is here. So in this case, my horizontal asymptote, the degree is higher on the top than the bottom. So I don't have a horizontal asymptote, but I do have a slant. And unfortunately, we can't use synthetic division because there is no simplified form, and my denominator is power of 2. So that means I'm going to have to use my long division. So I'm going to put 2x squared plus 1 on the outside. I'm going to put x cubed plus 2x squared, put that placeholder, 0x plus 4 on the inside. And then I'm going to long divide. So I'm going to multiply by 2x. 2x times 2x. No, I'm not going to multiply by 2x. I'm going to multiply by 1/2 x, right? So 1/2 x. So 1/2 x times 2x gets me x cubed plus 1/2 x. When I draw my line, I'm going to change my sign. So I'm going to subtract. I'm going to subtract. So I end up with, oh, no, I messed up. I messed up, guys. I got to have a placeholder. So I need to have a plus 0x plus 1. Okay, so now when I multiply, I get plus 0x squared plus 1/2 x. There you go, that looks better. Then when I draw my line, I'm going to change my signs. So my front cancels, and I end up with 2x squared. Sorry, my screen moved on me. So I end up with 2x squared minus 1 half x plus 4. And then I'm going to multiply by 1. Now, I don't even have to finish this out, okay? Because we have the linear portion. We don't care about our remainder, okay? So we don't even have to finish this out. So my slant asymptote is y is equal to 1 half x plus 1. If you want to finish it out, you can, but you're just finishing out for a remainder that doesn't matter when it comes to slant asymptote. So I can come over here and I can start at 1. I'm going to go up 1 over 2, up 1 over 2. And again, I'm going to be nice and accurate with this so that I know that I can have any points. Okay, so there's my asymptote. So all I have is a slant asymptote. That's kind of weird. Okay, well, let's keep going. So my x-intercept, remember, is when we set our top equal to 0. I don't even want to try and solve that. I couldn't factor that, so I don't even want to try that. So I'm going to put, I don't know. Okay. Who knows? Let's do a little bit more investigating because you know what? Y's are typically a little bit easier because remember our y-intercept is our ratio of our back. So that means my y-intercept is 0, 4. Yep, that was a whole lot easier. So 0, 4. Okay, that's all I got from the key elements, okay? So I have no asymptotes. I only have one domain section because I have no vertical asymptotes. So what in the world is going on? So at this point, this is when you just kind of investigate, okay? And the only way we have to investigate is to plug in. So I'm just going to start plugging in some numbers, okay? I'm going to plug in, I'm going to go 2 to the left of the point that I know. So I'm going to plug in -2 and -1. And I'm going to go 2 to the right, so 1 and 2. All right, and once again, I've done the math for us. So when we plug in -2, I get 4/9. So -2, 4/9 would be somewhere around here. When you plug in -1, you get 5/3, or in other words, you get 1 and 2/3. So -1, 1 and 2/3 would be something like this. When I plug in 1, I get 7/3, which is the same as 2 and 1/3. So 2 and 1/3 would be about here. And then when I plug in 2, I get 20/9, which is the same as 2 and 1/9. So 2 and 1/9 is just barely past my point right there. Okay, so this is a funky graph, but let's put together, just like we put together our points and our asymptotes before. Let's put together our points and our asymptotes. The points I need to connect, the asymptotes I need to draw near. So I'm going to start here, and what happens? I come down, and then I draw near that asymptote. I have no math that tells me I'm going to cross it, so I'm just going to stay on that side of it. I'm going to come down, I'm going to connect my dots, and I'm going to draw near that asymptote and try not to cross it. Okay, so this is a completely funky, crazy one. That doesn't mean that it's not a rational function. It is a rational function. We have a polynomial on top, we have a polynomial on bottom. It just has a lot of really, really weird characteristics, and that's okay. So if you find yourself in the situation where you go through all your key elements and nothing makes sense, just start plotting points. Plot some points, and then remember at the end of the day, what are we doing? We're plugging in our points. And we're connecting our points, and then we are going towards our asymptote. Okay. All right. So I hope all this made sense. If not, go back, rewind, watch again. Um, Before you move on to your homework with a substitute, you and your table partner are going to do an activity, a card sort activity that sorts equation, the factored form of the equation, and then characteristics and the graph. Okay, so a card sort to do. When you get done with that card sort, show the substitute, and then the substitute will give you your homework. Okay, the homework today is going to be a worksheet. It's graphing. Okay, it is graphing. So the homework for today will be a worksheet. So the substitute will give you that. We are going to do the worksheet a little bit different this time. We had a lot of issues with uploading it to Schoology. So this time you're just going to turn it into me in class. Okay, so first block people, you're going to turn it into me in class on Monday. Second block people, you're going to turn it into me on, I'm sorry, I don't even know my hours this year. Third and fifth, you're going to turn it into me on Monday. And then eighth, you're going to turn it into me on Tuesday. And again, this is just for completion. So I just want you to try every single one. Now, remember, I'll still give you the 24 hours. So if you want to get some things clarified with with me on Monday, you can. And third and fifth, you can still turn it in on Tuesday. And then eighth block, you can still turn it in on Wednesday. Okay. If you want to get some clarification going on, but we're just going to turn it in. My hope is, as I'm teaching, I'm going to look them over and get them right back to you. And then when the final deadline has passed, then I'll open the key on Schoology for everyone to see. Okay. We're going to try it that way this time, see if it works. Okay. Okay. So do your card sort. And then make sure it's all correct, and then get your homework. And I hope you have a wonderful weekend. Have a great rest of class and have a wonderful weekend, guys.